Structural analysis is like solving a puzzle, but instead of pieces, we use math and physics to understand how buildings stand up. It's the science of making sure buildings are strong and stable. We don't want them collapsing, right? This process is super important because it keeps us safe. By understanding how forces like wind, earthquakes, and even the weight of the building itself impact the structure, engineers can design buildings that can withstand these forces. Structural analysis helps engineers choose the right materials and design elements like columns and beams to create safe, strong, and efficient buildings. Without it, our buildings would be as shaky as a house of cards. Imagine a building as a series of frames like picture frames joined together. That's the basic idea behind the portal method. It simplifies complex structures into smaller, more manageable frames. This method assumes that the connections between beams and columns are rigid, meaning they don't bend easily. It also assumes that the beams mainly bend while the columns mainly carry the weight. The portal method is like dividing a big problem into smaller, easier ones. It's commonly used for analyzing multi-story buildings subjected to wind and gravity loads, making it a popular choice for designing buildings quickly and efficiently. The factor method is like a more refined version of the portal method. It still uses the concept of frames, but it considers the flexibility of the connections between beams and columns. This method assigns factors to different parts of the frame based on their stiffness. Stiffness refers to how much a material resists deformation and distress. By accounting for the flexibility of connections, the factor method provides a more accurate analysis of the forces acting on the structure. This method is particularly useful when dealing with irregular building shapes or unusual load distributions, offering more flexibility in design. Cantilever method, understanding structures that defy gravity. Ever seen a diving board or a balcony jutting out from a building? That's a cantilever, a structure that's supported only at one end. The cantilever method helps us understand how these structures work. This method focuses on analyzing the bending moment and shear forces within the cantilever beam. A bending moment is a measure of the bending effect on a beam, while shear force refers to the force that causes parts of a material to slide past one another. The cantilever method is crucial for designing balconies, overhangs, and even bridges. By accurately calculating the forces involved, engineers can ensure that these structures are safe and stable, even when they seem to defy gravity. Choosing the right method, a structural analysis guide. Each structural analysis method has strengths and weaknesses. The portal method is simple and quick, ideal for regular buildings. The factor method offers more accuracy for complex structures. The cantilever method is essential for analyzing structures supported at one end. Choosing the right method depends on the specific project. Factors to consider include the building's size and shape, the expected loads, and the desired level of accuracy. It's like choosing the right tool for the job. Each tool has its purpose.